Hello students, let's continue with the cards probability. Let's look into the first example. A card is drawn from a well shuffled pack of 52 cards. Find the probability of getting 2 of spades, a jack, a card of diamond and a king or a queen. Alright, 2 of spades. The first probability that we have is finding out for 2 of spades. The number of total cards that we have is 52. So the number of possible outcomes here is 52. That is our sample space. Let us denote the first event as even of getting 2 of spades. Now what do we mean by 2 of spades? We know in this 52 we have 13 spade cards. 13 in each of different suits and there are 4 suits. In this 13 spade cards, we want 2 of spades. 2 of spade as in they are talking about the number 2 in this spade card. Alright, the number 2 will occur only once in this spade cards. So when we talk about the number 2 of the spade card, there is only one card which has 2 on it and spades on it. So the possible outcomes would be 1 for this one and hence the probability of getting 2 of spades is the number of favorable outcomes I have 1 we have seen divided by the total possible outcomes which is 1 by 52. Now look into the second event. Let E2 denotes the event of getting a jack. Alright, now getting a jack. In this 52 total cards, we have 4 suits of them, right? The hearts, the club, then we have the diamond, and then we have the spades. Alright, in each of them, we know that the king, the queen, and the jack, that is the face card, each of them occur once into them, which means one of king would be hearts, king would be one would be club, then diamond and then spade. Similarly for jack also, for jack there will be once in each of the suits, one from hearts, one from clubs, diamond and spades. So the number of jack in all the 4 suits would be 4 each of them. So the number of favorable outcomes here is 4 and hence the probability of getting a jack is 4 divided by the total number of possible outcomes which is 42. Reduce it, so that is 1 by 13. Let E4 denotes the event of getting a card of diamond. We want to find out the probability of getting a card of diamond. How many diamond cards do we have into this one? Diamond card is what? One of the 4 suits, right? Diamond card is what? One of the 4 suits out of the total 52 cards. And we know that there are total 4 suits into this one and each of them has 13 cards into it. And diamond card is one of the 4 suits. So there will be 13 diamond cards into this total possible outcomes, that is the deck of cards. So the number of cards would be 13 and hence the probability of getting a diamond card would be 13, which is our number of diamond cards, divided by the total number, which is 52. Reduce it, we get the answer as 1 by 4. Now observe for this last event. What does it say? It talks about getting the probability of a king or a queen. All right. So think about this probability and try to answer it. Yes, we are talking about a king or a queen. Now, in this 52 total cards, we have 4 suits. Yes, and each of those 4 suits, we know that there are 13 cards, and in each 13 of them, what do we have? We have 3 face cards. Yes, each of them has 3 face cards. And out of this 3 face card, there is one king, and we know one queen, and the third one is jack, right? Similarly, for the second one also, we have king, queen and jack. For the third one also, king, queen and jack. And here also we have king, queen and then jack. So all of them, we have to find out the. So we know that there are king, queen and jack in each of these face cards. So we have to find out the probability of getting a king or a queen. First event is of king and the second event is of a queen. Alright, and in between we have a word or. What does this word or represents? That you have to use the addition theorem into this one. You have to add both the events together and then find out the probability. What you can do is one thing is that you can add the possibilities together and then find out the probability, or you can separately find out the probability of king and probability of queen and then add them together also. Yes. So the number of queens and the number of kings would be king and queen in each of them 4 suits, so there will be 4 king. Similarly 4 suits, so there would be 4 queens. So that is total number of kings and the queens is 8, and hence the possible outcomes here we have is 8. So the probability of getting a king or a queen is total number of possible outcomes is 8 divided by the sample space, which is 52. So after reduction we get it as 2 by 13. Now look into the second example. Find the probability of getting a numbered card when a card is drawn from the pack of 52 cards. Alright, we want to find out a numbered card. Let us first of all define the event. Let the event E is drawing a numbered card from the pack of cards. The total outcome for us is fixed, which is 52. In the last session, if you have seen, we have checked what is a number cards. We have seen what is a number cards. Out of this 52, we have 13 of each suits. In this 13, we have seen that there are face cards, there are ace cards and then there are number cards, right? The first that we have is face cards, total 3 face cards, the king, queen and the jack. Then next we have seen is an ace card which is only one. And then remaining of them are the number cards. Number cards is what? Remaining of them. That is 2, 3, 4, 5, 6 till 7. All of this are your number cards, as on this card there are numbers represented on them. Alright. And in each suit we have total 9 numbered cards. Alright. And there are total 4 suits. So here the number of favorable outcomes would be 9 into 4, which is 36. And hence the probability of drawing a numbered card is the favorable outcomes divided by the possible outcomes, which is 36 by 52. After reducing, we get it as 9 by 30. Now in the third example, we have a card is drawn at random from a deck of cards. Find the probability of getting 3 of diamond. We want to find out the probability of getting 3 of diamond. If you remember, we had one example solved as 2 of spades. I guess it is in the first example only. 2 of spades. What did we mean by 2 of spades? In the face card, we want to find out a card which has the number 2 on it. Alright. Similarly, here also we have 3 of diamond, which means out of all the 13 diamond cards, we want to see the number 3. So there is only one card which has the number 3 represented on itself. So there will be only one possible outcome for this one. As there is only one card which has a number 3, only one diamond card which has a number 3 on it represented. That is why the number of possible outcomes here would be only one. So let's define the event first. Event is drawing 3 of diamond from the pack of cards. Total number of possible outcomes, that is our sample space 52. Since there are 13 diamond cards, and in those 13 diamond cards there will be only one card which represents the 3 of diamond. So the possible outcomes that we have is only 1. And hence the probability of drawing a numbered card is 1 divided by 52. Now let's look into this example. A card is drawn from a well-shuffled pack of 52 cards. Find the probability of a non-ace card. Now what do we mean by a non-ace card? We want to find the probability of such a card which is non-ace, which means that card should not have ace card into it. Alright? Yes. Now, since there are 13 suits of each of, sorry, there are 13 cards, in each of the 14 suits. Alright? And in this 4 suits, we have total 4 ace cards, right? The number of ace cards in each of the 4 suits is equal to 1. In each of them, it is 1. So the total number of ace cards out of the 52 cards would be 4 into each of them. So 4 of spades, hearts, clubs and diamonds. So that is 4. But we don't want the ace card. We want a non-ace card, which means we want a card which is not an ace one. So if we subtract out of the total, if we subtract this 4 ace card, the remaining would be the non-ace cards. The cards which does not represent the ace into it, they will be your non-ace card. It could be your face card or it could be your number card also. That is okay, but there should not be an ace card. So hence the number of favorable outcomes, that is the non-ace cards, would be 52 minus 4, which is 48. And hence the probability of getting a non-ace card would be 48 by 52. After reduction, we get it as 12 by 13.